and welcome back to Teacher Gimbel's channel. Today we'll be going over Illustrative Math, Algebra 1, Unit 2, Lesson 5. Let's get started. Problem 1. Select all the points that are on the graph 4y minus x, 6x equals 12. So remember, when you have 2 points that are in parentheses like this with a comma, the first point represents the y and the second point represents the x. So in this case, x is equal to -4, y is equal to -3. To figure out if they're in their graph, all I'm going to do is I'm going to plug in these values into my equation, and I'm going to check to see if my equation is true. 4 times -3 is 12. We have double negatives here, so we're going to have 12 is equal to 12. This is equal to 0. This is not true, so it tells us that is not on our graph. Let's go ahead and do the second one. X is -1, y is 1.5. So we're going to plug in 1.5 minus 6 times -1 is equal to 12. 4 times 1.5 is 6. Minus 2 minuses make a plus. 6 is equal to 12. This is true, so this guy is in our graph. Let's go on to the next one. In this case, x is 0, y is -2. 4 times y, which is 4 times -2, minus 6 times 0 is equal to 12. 4 times -2 is -8. Minus 0 is equal to 12. Not true. Not in our graph. In this case, x is 0, y is 3. 4 times 3, which is y, minus 6 times 0 is equal to 12. 4 times 3 is 12, minus 0 is equal to 12. This is true. This guy is in our graph. X in this case is equal to 3. Y is equal to -4. We plug them in, just like we've been doing all along. Minus 6 times 3 is equal to 12. 4 times -4 is -16. Minus -18 is equal to +12. -16 minus -18 is not equal to +12. He's not in our graph. Now finally we have x is equal to 6, y is equal to 4. 4 times 4 minus 6 times 6. Is it equal to 12? Well, 4 times 4 is 16. Minus 36, is that equal to 12? 14, should be 16. Nope, that is not equal to 12. That is not our answer. And that's how we do it. Easy peasy way to find out if any of our points that we are given are in our graph. Pause the video if you need a second to go over this or look at my answers as I move on to the next question. Problem 2. Here's a graph of the equation x plus 3y is equal to 6. Select all the coordinate pairs that represent a solution to the equation. So we could go ahead and plug in, just like we did on the last one. That will work. But because we're given the graph here, we're going to use the graph in this case. Now, this is our x value, this is our y. So we say x, y. Is that point on the line? If it is, we're good. Now I'm going to write down my correct answers because we're going to have to scroll down to see the other ones. B, so we have A, B, C, D, and F. A is correct. B, 0, 6. So 0, 6. Nope, he's not on the graph. That is not a correct answer. C, 2, 6, which means we go over 2, up 6. He's not on our graph. C is not a correct answer. Let's quickly go down and see what our last two options are. So for D, we're looking at 3, 1. E, we're looking at 4, 1. And F, we're looking at 6, 2. And we'll scroll back up to check if these guys are on our graphs. All right, so we have D is equal to 3, 1. So 1, 2, 3, 1. Yep, he's on our graph. D is good to go. E is equal to 4, 1. 1, 2, 3, 4. Then up 1. He is not on our graph. He's not good to go. F is equal to 6, 2. 1, 2, 3, 4, 5, 6. Up 2 would be over there. He is not on our graph. So these are the 2 points that are on our graph. So we know if we plug them into our original equation, it would come up with a statement that is true. Let's go on to the next question. And these are both accurate ways of doing exactly the same thing. A theater is selling tickets to a play. Adult tickets cost $8 each, and children tickets cost $5 each. They collect $275 after selling 8x adult tickets and y children's tickets. What does the point 30, 7 mean in this situation? Well, what this means is this is the number of adult tickets sold. So our x values equals adult tickets sold. Our y values are children tickets sold. children sold. Well, these are tickets. So we're going to say tickets sold. This is our X, this is our Y. So 30 means there were 30 children tickets sold. Our Y means 30 means 30 adult tickets sold because that's our X. And the 7 means 7 children's tickets sold. So when you sell 30 adult tickets and 7 children's tickets, you make $275. And these are all the different combinations of the number of adult tickets and children tickets that you could sell that will get you the same profit of $275. So if you have a question ever like this, just go look, define your X's, define your Y's, and that will easily be able to help you figure out what your point means. It's your X, comma, your Y. Let's go on to the next question. Problem number 4. In this problem, technology is required. Priya starts with $50 in her bank account. She then deposits $20 each week for 12 weeks. Write an equation that represents the relationship between the dollar amount in her bank account and the number of week savings. So her bank account is going to equal, well, she starts with $50, and then each week she gets $20 more. So we're going to put 20 times W, where B is our bank account, W is the number of weeks. And that is our equation. 2. Graph your equation using graphing technology. Mark the point on the graph that represents the amount after 3 weeks. So I'm going to go to my handy dandy graphing calculator. I'm going to say B is equal to 50 plus 20W. And there we go. We got our graph. And we got to zoom out here because she starts at $50. Now in this case, I'm going to do this. You don't have to if you want to. I want my Y to just be between 50 and let's say how much money she might make. Let's say $500. $500. So it zooms in just on those values. Now my X values, she only goes for 12 weeks. So I'm just going to make my X values just those 12 weeks that we are looking at. And what this does is this makes our graph a lot easier to look at. Like it makes a lot more sense in this case. And that's just by switching how much money I thought she might make, which is our Y, and how many weeks we have, which is our X. Mark the point on the graph that represents the amount after 3 weeks. Well, after our first week, it's this much. Second week is this much. Third week is this much. So I would mark this much. And we see that she has a little bit more than $100 after 3 weeks. All right, let's go on to the next question. Our next question is, how many weeks does it take her to have $250 in her bank account? Mark this point on the graph. So we're going to use the graph to use this question. So 250 weeks, or $250 is going to be somewhere between $200 and $300. And the amount of time it's going to take her is going to get right about, let's move him over. Let's do that again, right about over here. And moving my face, we can see it will take her about 10 weeks to get her $250. And we can actually do that using the equation as well. So let's go ahead and do that using the equation so you can see the 2 ways to do these types of questions. So we want to know when she has $250. Now B represents her money in the bank account. So we're going to say 250 is equal to 50 plus 20 weeks. And we're now solving for the number of weeks it takes her to get there. So I'm going to subtract 50 from both sides, which gets me 200 is equal to 20 weeks. I'm going to divide by 20, and I'm going to get weeks equals 10, which is just what we saw on the graph, that it takes her about 10 weeks in order to get that amount in her bank account. So most of these questions, if you have an equation and a graph, you can solve using either way, and both of them are equally accurate. Let's go ahead on to the next question. During the month of August, the mean daily rainfall in one city was 0.04 inches with a standard deviation of 0.15 inches. So that means on average, there was 0.04 inches, and kind of usually it was a little bit more than 0.14 or less than 0.14 by about 0.15 inches. In another city, the mean daily rainfall was 0.1 inches, so considerably less, with a standard deviation of 0.05 inches. Han says both cities had similar patterns of precipitation in the month of August. Do you agree with Han? I do not agree with Han. Because a standard deviation of 0.15 means that city A was 0.04, but sometimes it ranged to 0.19, because that's 0.04 plus 0.15. It ranged all the way up there. And sometimes it ranged down, probably 0, because we don't have negative rainfall. However, in City 2, the mean was 0.01, which is kind of close to 0.04, but it only ranged, the deviation was only 0.5, so it went between 0.01 and 0.6 at a regular basis. So I would say there's a lot more rain in City 1, and Hannah's wrong. But if this confuses you, make sure to go back to Unit 1 and look at some of the lessons about standard deviation, because that's an intuitive process to help you remember that. And that is in Unit 1, Lesson 13, and I've got a video for that already posted. Problem number 6. In a video game, players form teams and work together to earn as many points as possible for their team. Each team can have between 2 and 4 players. Each player can score up to 20 points in each round of the game. Han and 3 of his friends decided to form a team to play a round. Oh, maybe this is the same Han. Write an expression or an inequality for each quantity described here. If you use a variable, specify what it represents. The allowable number of players in the team. Well, each team can have between 2 or 4. So we're going to say 2 is less than or equal to, because you're allowed to have 2. P is the number of players. 4. When I read statements like this, I like saying P is in between 2 and 4. And it can be equal to 2 and 4 because it can be equal. So thinking about it like that is easier than saying 2 is less than or equal to P, which is less than or equal to 4. P is in between 2 and 4 and is allowed to be equal to 2 and 4. The number of points Han's team earns in one round if every player earns a perfect score. So each player earns a perfect score. So if P is the number of players, we're going to have 20 times P, because 20 points for each player, and each player earns a perfect score. 3. The number of points Han teams earns in one round if no player earns a perfect score. Well, if no player earns a perfect score, I'm pretty sure that will be 0 points, because that's the number of points the players made in each round, and they can score up to 20, and that's assuming that they can also score 0 points. Let's go on to the next question. Well, pause. Let's rethink this, because I was like, 0 doesn't really make sense in this case. If no player earns a perfect score, that doesn't necessarily mean they earn no score. So I immediately read that and I said, oh, it's no score. But let me look at this question again. If no player earns a perfect score, what that means is that we have 80 would be a perfect score if all 4 players earned a perfect score. And then we would have less than 80. So no players earned a perfect score, so it would have to be less than 80, where S would be the score. We could also simplify this guy above, because there's 4 players, and rewrite this as 20 times 4, because we remembered Han and 3 of his friends form a team. So there are 4 players on the team. 4. The number of players in a game with 6 teams at different sizes. 2 teams have 4 players each, and the rest have 3 players each. Well, if 2 teams have 4 players, that would be the number of players on 2 people teams, on the 2 teams with 4 players, plus the rest of the teams have 3 players, and the rest of the teams, so 2 have 4 players, the rest of the teams mean there's 4 teams left, 4 teams have 3 players, and that will get you the total number of players. Finally, the possible number of players in a game with 8 teams. So either, if there's 8 teams, we are going to have this, every team is a small number of teams. So 8, every team has 2 players. The smallest number of players could be 16. And then we're going to have team players. And then the largest number of players would be if every team has 4 players. And 8 times 4 is 32. So the number of team players is somewhere in between 16 and 32. And we're not sure where it is, where team players is the total number of people playing. Pause if you need to go over that again, and we're going to move on to problem number 7. So for problem number 7, we have a student on the cross-country team runs 30 minutes a day as part of her training. Write an equation to describe the relationship between the distance she runs in miles d and her running speed in miles per hour when she runs. So if she's running at a constant speed of 4 miles per hour for the entire 30 minutes, well, the distance is going to be how much she ran, which is 30 minutes. And we have to remember we are talking miles per hour. So it's not going to be 30 minutes. We're going to call it a half an hour. And then the speed that she went would be 4, because distance is equal to time times rate. Number 2, if she ran at a constant speed of 5 miles per hour for the first 20 minutes, so we'd say 5 times 20 over 60, which is how I turn my minutes into a fraction of an hour, plus we're going to go ahead and say 4 miles per hour for the last 10 minutes. So it's going to be 4 miles per hour for the last 10 minutes out of 60. And if you wanted to simplify this, you could simplify it by saying 5 times 1/3 plus 4 times 1/6 to get the correct answer. Number 3, at a constant speed of 6 miles per hour for the first 15 minutes, so 6 miles per 15 out of 60, and then at 5.5 miles per hour for the remaining 15 minutes, so 15 out of 60. And you could go ahead and you could simplify this if you would like to, and you would then get 16 out of 50. Well, 15 is a quarter hour, so that would just be a quarter plus 5.5 times a quarter. All right, 4. At a constant speed of 8 miles per hour for the first 6 minutes, so A times 6 over 60, plus 6.5 miles per hour, 6.5 miles per hour, for the remaining 24 minutes, with 24 over 60. And we could simplify the fractions. It would be A times 1/60 plus 6.5 times 4 over 10, 2 over 5. 2 over 5. And I simplified that fraction in my head, but if you need to take a second to pause this video to simplify the fraction yourself, go ahead and do that. Finally, at a constant speed of 5.4 miles per hour for m minutes, 5.4 miles per hour for m minutes, so we're going to put m over 60, and then at b miles per hour for n minutes, plus b miles per hour at n over 60. And we're going to go ahead and do it just like the ones we did before. We can't simplify in this case because we don't have anything to simplify, and that would be our expression. All right, let's go on to the last question. I believe it's the last question. Oh, 2 more questions left. Problem 8. We're now going to move on to problem 8. Now, in problem 8, this is one of the few cases where the answer that I get doesn't actually match the answer that you see in illustrative mathematics. So if you're looking at the answer key, my answer looks different, and I'm going to explain to you how I do it. If you have a different way of doing it, please post it in the comments below, because I'm not 100% sure where they got their answers. Problem 8. In the 21st century, people measure in length in feet and meters. At various points in history, people measured length in hands, cubits, and paces. There are 9 hands in 2 cubits, and there are 5 cubits in 3 paces. So, 1. Write an equation to express the relationship between hands and cubits. So we know that there are 9 hands in 2 cubits. So I'm going to say 9 hands is going to equal to 2 cubits. So if I want to express a relationship between the two, I would divide both by 2, and I would say 1 cubit is equal to 9 divided by 2, 4.5 hands. Alternatively, if I said, again, starting where I wanted to start with 9 hands is equal to 2 cubits, if I wanted to define it in terms of h, I would just say I divide both sides by 9, and I'd say 1 hand is equal to 1/8 of a cubit. And that's how I would do that. And 1/8 is wrong because I simplified that in my head, which I tend to do when I simplify, and I'm not so careful. It's going to be, well, 2 divided by 9 stays as 2 divided by 9. We can't simplify that. So 1 hand is 2/9 of a cubit. 1 cubit is 4.5 hands. So we're going to use this for question number 2. 2. Write an equation to express the relationship between hands and paces. So we know there are 5 cubits in 3 paces, and we want to define this in terms of hands. Now I know for each cubit that is 1 cubit is 4.5 hands. So if I have 5 cubits, I'm going to have 5 times 4.5 hands, because there's 4.5 hands in each cubit, is going to equal 3 paces. 5 times 4.5, pull out your handy dandy calculators or go ahead and do your mental math, gets us 22.5 hands is 3 paces. And if I want to know how many hands are in one pace, I would divide both sides by 3, divide by 3, and I would have P alone, and 22.5 divided by 3 gets me 7.5 hands in each pace. And that's how I would do this question. So one pace is equal to 7.5 hands. All right, let's go on to the last question. Problem number 9. The table shows the amount of money, A, in a savings account after M months. Select all the equations that represent the amount of money, A, after a number of months, M. So let's go ahead so we can see all of our answer choices. And let's look. So after 5 months, there was $1,200. After 6 months, there was $1,300. After 7 months, there was 14. So quickly, I'm going to see a pattern. I see each month there's an additional $100. So that's just a pattern that I noticed, which is going to help me. So A is 100 times M. Well, at 5 months, this would be 100 times 5, which would be 500, and we have $1,200, so nope. A is equal to 100 times months minus 5. Well, and I'm just going to keep using my first data point to see if it works. 105 minus 5, that's going to get me 0. Nope. A minus 700 equals 100M. So if I'm going to calculate this one, well, using my first data point, A is the amount of money, so it's 1,200 minus 700. Is that equal to 100M? Well, let's check. Is 500 equal to 100 times 5? That does work. So let's go ahead and check it for another data point. And actually, let's go ahead and do it for 8 months. So we have 1,500 minus 700. Is that equal to 100 times M? Well, M in this case is 8 because we're talking about 8 months. So let's go ahead and say 8. And then we're going to have 1,500 minus 700 is 800. And that is equal to 800. So this looks like it is correct. And I'm going to circle it. D. Is A minus 1,200 equal 100M? Well, if it worked with 700, it's not going to work with 1,200. So I'm going to cross them out. Is A equal to 700 plus 100M? Well, in this case, I already verified this using 2 points. And I notice if I add 700 to both sides, what I get is this equation. So instead of verifying again, I'm just going to say, hey, I realize it's the same equation, and therefore it has to be correct. Now, is A equal to 1,200 plus 100M? I notice he's the same as that guy, and I already know he's not going to work. And finally, is A equal to 1,200 plus 100M minus 5? So let's go ahead and test this hypothesis. So A is 1,200. Is that equal to 1,200 plus 100 times M, which is 5, minus 5? Well, for 5 months, that works. Let's see if it works for 6 months. So A for 6 months is 1,300 equal to 1,200 plus 100 times 5 minus 6. Oh, 6 minus 5. I think sometimes talking and doing math and writing at the same time is tricky. So we have 1,200 plus 100 times 1 is going to give me 1,300. I think that is going to work because each time this number, our value, this M value is going to go up. And we're going to multiply it. So the first time we multiplied it by 5 minus 5, which is 0. The next month it's 5 minus 6 minus 5, which is 1, which gets us $100. 7 minus 5 is 2, which is going to add on $200, which is that difference after 2 more months. So this guy looks correct too. So if you're having trouble with these questions, you just plug in to verify. If you can logic using the equations, I always recommend use your logic to determine which ones are accurate and which ones are not. All right, I hope you like this video. If you have any questions, please post them in the comments below. Like and subscribe. I think it's over somewhere in that corner. And I'm looking forward to seeing you in the next one.